In this tutorial, we'll give an overview of tNavigator tools for water flood analysis. This option was successfully tested on giant field with thousands of wells and on small sectors as well. Now we'll work with streamlines, drainage graph, table, and network. I start with the Maps tab. Select to 3D Map and run model calculations. Uncheck Show Mesh and check Streamlines. Streamlines are built at each time step based on pressure gradient, so the streamlines are orthogonal to isobar lines. Streamlines can be used as explicit illustration of drainage directions, the directions of pressure support. For default streamlines have a color of the map we are standing at, pressure at my case, but we can use different options. Now, for example, we can use unique color for streamlines for each well. Let's press Settings. In this dialog, we select Use Unique Well Color. Now we can see that each producer has its own streamline color. The main parameter for streamlines is density. It defines how many streamlines will trace from one well. 5M3 for one streamline is used for default. Average amount of streamlines for each well can be obtained by dividing well rate by this density. So if this density is a large number, few streamlines will trace from one well. Now let's change density to 20M3. Apply and see the difference. Let's change it to 1. Apply and see the difference again. Now we suggest to use default value 5M3. It is optimal for the most part cases. If you want to see streamlines only for specific wells, use Streamline Filter. Now we press Well Filter button. In Well Filter, All wells selected. This filter will be used for wells visualization. Then choose Streamline Filter in the drop-down menu. Deselect All and check the well you want to see streamlines for. It will be used for streamline visualization. Then switch back to Well Filter 1. Now we move Time Slider and we can see all wells, but streamlines are visualized only for selected one. Now let's go to Waterflood tab to have an overview of a drainage table. It is a quantitative estimation of efficiency of your water flood system. This table can be calculated for any time period. Move the time slider to the time step from which you want to start calculations. Then press Compute in the bottom right corner. Now we can see time slider moving. It is not the model calculation, but just calculation of drainage table. The table can be presented for ejectors or for producers. I select Group by Injectors. Values Absolute. On the left, we can see the list of injectors. For each injector, liquid is the amount of injected water in reservoir conditions. Oil is the amount of oil produced by responding producers that are connected to this injector via streamlines. On the right, we can see the list of responding producer. Now for each producer, there is an amount of produced liquid in reservoir conditions and produced oil in surface conditions. So, this oil and this liquid were produced by these wells due to pressure support of this injector. As a reservoir, we can see water injected to reservoir that doesn't influence directly on production. The idea of this table is that a sum of this column is equal to this value. The same for liquid. Now let's check it. I select a part of this table and copy it to Microsoft Excel. Then I sum this column and see the value as a result. And the same for liquid. Using this table, we can have an estimation how much oil and where we can lose if this injector will close for repairing. Of course, there will be a flow redistribution, but anyway, it can be taken into account. Now, let's switch to value. Relative. In this case, for each injector, there is a list of responding producers and fractional contributions of this injector to their oil and liquid production rates. The same way, this table can be grouped for producers. We have producers on the left and a list of connected via Streamlines injectors. Let's go to Maps tab again. I select 2D map. Uncheck Color by Mesh. Check Show Wells, Well Names, and check Show Drainage Network. Press Settings to use unique color for wells. Thickness of the line between wells is proportional to the value of stream according to Streamlines. One line of network is built by the line with minimal time of flight of all streamlines at this time step. Drainage network is built for the period which is used to calculate drainage table. So, if you need to calculate network for another time period, you should recalculate drainage table for a new time period first. Thank you for your attention. Enjoy working with tNavigator and see other training tutorials for more details.